So this is pop quiz 2, which is related to circular motion. 18th century clock sometime used as a conical pendulum to measure the regular period of time. A conical pendulum consists of a bob with mass m and fixed at one end of a wire of length L. The bob is said to follow a circular path in a horizontal plane, and the wire makes an angle theta with the vertical. Add to a diagram, show the two forces acting on the bob. So the two forces which are acting on the bob, one is the weight of the bob which is acting downward, another one is the tension in a string. Derive the following equation for an angular velocity omega for a bob, that omega is equals to under root g divided by L cosine theta. So as I mentioned in A2, you will find there are short derivations are there, even though you don't see this formula, but you must be able to derive. So weight is acting downward and the tension is there T. The tension will have two components. One of the component of a tension which is with an angle that's equal to T cosine theta. And the other is perpendicular, like opposite to the angle, that is T sine theta. So see, T sine theta is responsible for the circular motion and T cosine theta balances with the weight. So we have T cosine theta balances with the weight, and we have T sine theta that is responsible for the circular motion. So we can say that is T sine theta is the centripetal force. And centripetal force is given by mr omega square. So if you solve like this, say this is equation 1, this one is equation 2. So if I solve equation 2, so I can say T sine theta is equals to mr omega square. Now, if I substitute, and what about r here? The radius, like this is T sine theta is equals to mr omega square. Now, what about the radius of this circular path? So we have this length L. So this length will also have two components. The component of the length which is with an angle that is equals to L cos theta, and the component of the L which is opposite to the angle that's equal to L sine theta. So L sine theta is actually equals to radius of a circular orbit. So we can say that the radius is equals to L sine theta. So in place of radius, I can substitute L sine theta. So I can say T sine theta is equals to M, and in place of radius, I can say L sine theta omega square. And sine theta will cancel with sine theta. So we can say T is equals to ML omega square. And this is one equation. After solving equation 2, we get another equation. So if I substitute the value of a T here in equation 1, if I substitute the value of the T in equation 1, so I can say in place of T, it is ML omega square cosine theta is equals to W, which is equals to weight. And W is equals to mg, so we can further simplify ml omega square cosine theta is equals to weight, which is mg. Here m will cancel with m, mass will cancel with mass. So if you want like omega, so L and cosine theta is multiplied, the other side it will be divided. So cosine theta or omega square actually. So omega square is equals to g divided by L cosine theta. If I need omega, so we'll take a root, square root both sides. So we can say that omega is equals to under root g divided by L cosine theta. Is it clear? This short derivation, a 4-mark derivation is there. The reason why we convert the radius into L sine theta, because the final derived formula, you don't have sine theta. So it means we have to cancel out sine theta. That's why we convert the radius into the component of the length. Is it clear, this one? The next one, a clock requires a period of a bob to be 5 seconds. The length is there and the angle is there. Deduce whether this uh, arrangement leads to a required period. So you just have to substitute the values as we already derived. So because this formula is there, omega is equals to under root g divided by L cos theta. So we'll use that value to work out omega, and from omega we'll work out the time period. So omega is equals to under root L divided by, sorry, under root g divided by L cosine theta. So we'll substitute omega will be equals to under root the value of the gravity 9.81, the length that is given 6.4, and the angle is 13.9. So this will give us a value for omega, which is 1.26. And then we have the formula, like the relation between omega and the time period. Omega, when we talk about like omega is equals to theta divided by t, that's a formula for omega. But when one complete revolution, one complete rotation, that time is known as a time period. And in that case, omega is equals to 2 pi divided by t. So t will be equals to 2 pi divided by omega. So 2 pi divided by omega will get the value for t. And we'll compare this value of a t. Like for finding the value 2 pi divided by omega, so 2 pi divided by 1.26, and this will give us a value for time period. And this time period, if it match with 5 seconds, so we'll say it is consistent with our result. Otherwise, if it, and check one thing, the uncertainty percentage uncertainty should be within 10%. If it is more than 10%, we'll say no. If it is less than 10% or equal to 10%, we'll say yes.